Hey guys, welcome to our Unit Exam 3 review video. This is going to be a good aid for you guys to use in studying for your Unit 3 exam. For this part 1, we're going to be going through the first 4 lessons or so. I think it's five lessons, and we're just going to go over the main ideas or the main concepts of each lesson. We'll see some examples and exactly what it is I want, or exactly what it is that you guys should be studying for. So we started our unit with lesson 1, the Cartesian plane. In the Cartesian plane, we just went over some vocabulary. We went over what the Cartesian plane was. It was two number lines that intersect at a right angle. Our Cartesian plane is also known as our coordinate plane. We have an x-axis, which is the horizontal axis, and our y-axis, which is the vertical axis. Our origin is at the 0, 0, 0. And then we have 4 quadrants, so it's important for us to know that quadrant 1, 2, 3, and 4, it goes in a counterclockwise position or in a counterclockwise orientation. That's all we cared about in lesson 1. We jumped into lesson 2 where we first get introduced to the distance formula. Now, as you guys have seen, the distance formula is used throughout the entire unit. So we see this formula come up every single lesson. So this is where it came from. We're actually going to derive it, and we're going to talk about it. So the distance formula does derive from the Pythagorean theorem. We went over a few things to note. We went over horizontal distance, which is going to be x2 minus x1. And we have that vertical distance is just y2 minus y1. So that's where we get these numbers from. And if we're talking about Pythagorean theorem, that's how we derive this equation. This is our big dog. So please refer to your notes if you want to see the complete derivation. We also talked about the midpoint. The midpoint was pretty much just taking the average of the 2 points. So if we had 2 x values, we added the x values and divided by 2. We have 2 y values, we added the y values, and we divide by 2. This tells us that if we're dividing by 2, we're finding the halfway point of my x's. And when we're dividing by 2, we're finding the halfway point of my y's. If we find the halfway point between both of them, we actually create the point M, which is our midpoint. Here's our very first example. So we want to know what the distance is between these 2 points. So by now, we should all have the distance formula pretty much on lockdown. But I'm going to go ahead and write it down anyways, so we can see it a second time. X sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. We're going to go ahead and label this point x2, x1. Since this is our first point, this becomes x1, this becomes y1. This is our x2, this is our y2. When we plug stuff, when we begin to plug in these values into our equation, we get d is equal to the square root of 5 minus negative 4 squared plus the quantity of 2 minus negative 1 squared. These two negatives cancel out, or they actually become positive, so we end up with the distance is equal to 9 squared plus these two also become positive, 3 squared. So if we square those values, we get 81 plus 9, or square root of 90. So you can actually reduce this by creating factor trees. So if we do a little factor tree, we get 9 and 10. We know that these two are 3 and 3, and this is 5 and 2. So when it comes to factor trees, we just want pairs. We have only one pair of numbers, or one couple. So the way I explained this, or I taught this, was using that club analogy. If you're club and you go to, if you're going to a club and you are single, here's my radical club. If you're single, you get bored and go home. I'm sorry, if you're single, you're going to stay inside the club. Well, the two numbers that stay inside are going to be 5 and 2. Well, what's 5 times 2? That's just going to be 10. And then outside, the couple, they go home, so they're a couple, which means who's outside? It's just going to be the number 3. So this is our reduced radical. So my distance from this point to this point is just 3 root 10. So whenever we're doing slanted distance, that's when we apply the distance formula. Here's another example. We're going to look at the midpoint. For the midpoint, again, we have 2 points. Our first point, x1, y1, x2, y2. From here, we're going to go ahead and find the midpoint. Visually, for you geometric people, you can see that the midpoint is already here, and you can just give me the coordinates of 3, 3, and that's fine. But to do it more algebraically, when I don't give you a graph, we're going to go ahead and apply the formula. So we know my midpoint is going to be the average of my two x's, so 5 plus 1 over 2, and the average of my two y's, 2 plus 4 over 2. This gives us 6 over 2, 6 over 2. We divide that or simplify, and we end up with 3, 3. That would be the point, 3, 3. This is the point. So this becomes my midpoint. Meaning if I were to cut this segment in half, the half point would be at 3, 3. So again, that's just easy applications of both of these formulas. We also talked about x distance and y distance, or horizontal distance and vertical distance. We explored how to find this, and before we actually derived the distance formula, we used this idea, this notion. So when we looked at this one, we ended up with x1, y1, x2, y2. So to find horizontal distance, we just covered, or we just said that that was x2 minus x1. And to find vertical distance, this was y2 minus y1. So again, those are important concepts that we're going to see later on in the lesson of slope. So second look at partitions, slopes, perimeter, and area. So we're going to continue on. With lesson 3, we talked about partitions. So again, just to recap, lesson 1 was Cartesian plane, lesson 2 was distance and midpoint, lesson 3 is partitions. In partitions, we can do this visually as well. We know that, or a few words, is the ratio. The ratio is from R to S. That's the ratio that we're cutting or partitioning our segments into. Now when we talk about partitioning, this is the definition, is to divide a segment into two segments with a given ratio. So here we had the segment AB. We cut it we cut it with the point P. If I were to take this segment and measure it equally throughout the segment AB, we would actually come up with several more points. This segment would be one more maybe here, and then another one maybe here. If that's the case, we can say, all right, how many equal parts do we have in this portion of it? So if we count, we get 3. And how many equal parts do we have in this segment? We get 1. So my ratio to this one would be 3 parts to 1 part. So we would say that we would partition the segment with a ratio of 3 to 1, or 3 parts to 1 part. We're going to take this notion of partitioning and apply it to an actual example. So here we have a segment on a grid. Now, to find an equal amount of distance, well, this one is asking us to use what we know about, remember guys, always read directions. It says use what we know about partitions to find the coordinate of a point P that partitions segments AB into a ratio of 1 to 2. So we want a ratio of 1 to 2. We want to find out what the slope is from here to here. Actually, we want to find out equal amounts of segments that we can cut this thing into from A to B. So I'm going to go ahead and grab a different color. And if we actually look closely, we can rise about 2 units and then across 1, 2, 3, 4, 5. This gives us a good place to partition, or to create one partition. If we continue on this way, we can rise 2 more units and go across 5 more. 1, 2, 3, 4, 5. It cuts it again there, and then we can go up 2 more units and we go 5. So by doing so, we end up with 3 equal partitions, or 3 equal parts. We got 1 part there, a second part there, and a third part there. All 3 parts are equal. So now if we're trying to cut this into a 1 to 2 ratio, we're going to look at the 1 part, or this first part, so that's 1 part, to Well, how many are left over here? 2 parts. So if we cut it in this equal distance, then this actually tells us what the ratio is. It's 1 to 2. So we're trying to find or locate the point, which is this point, where we decided to cut this segment so that it could partition into that ratio. This point itself, when we follow on our number line, we get -1, and our y value is going to be 4. So my point P for partitioning is actually going to be the point -1, 4. That is my partitioning point. So if we keep going, we can actually find the same exact point by applying the partitioning formula. So given any two endpoints or any segments that's graphed on a coordinate grid or a Cartesian plane, we know we're going to have an x1, y1, x2, y2. They're going to give us, not the ration, but I should say ratio. They're going to give us a ratio r to s. The following formula will render the coordinates of the partition. So let's apply this formula. Now, the easy way to remember this formula is we're just taking the x2 plus x1. So that's the same thing as our midpoint. So we actually derived this in class, or you guys did it as a group. We had the x2 plus x1. The only difference is instead of dividing by 2, we're dividing by this r and this s. So we know that we have to multiply r times x sub 2 plus s times x sub 1, and in the bottom r plus s. Very similarly, we have that r, this y sub 2, plus my s, y sub 1, and we divide by my r plus s. So to actually come up with this partitioning formula, it's not that difficult. You guys derived it in class. Let's see an application of it. Here, I really didn't give you guys the coordinate grid, but I gave you guys 2 points. I gave you guys point A and point B. It says find the coordinates of the point P that partitions segment AB into the ratio 3 to 2. So instead of trying to find out a slope or trying to cut this segment into an equal amount of pieces, I can just jump straight into the partitioning formula. Again, to derive my partitioning formula, all I have to do is remember my midpoint. Well, I know that my midpoint is going to be an x2 plus some x1. And I know that there's going to be a ratio of r to s. Well, that r to s is going to be outside in that order, r, s, divided by r plus s. And again, very similarly, we have that there's a y sub 2 plus some y sub 1. We're going to divide by r plus s, and the r plus s up here as well. So this actually derives the partitioning formula. Let's go ahead and just plug in these values. So at this point, we can just say, all right, well, since we're going from A to B, A is going to be my first point. If A is my first point, this has to have the sub-index of 1 and y1. This is my second point, or my number 2, so I'm going to have x sub 2, y sub 2. I plug directly into my formula. My r is 3. My x sub 2 is 6. My s is 2. My x sub 1 is 3. Divided by r plus s. Oh, I'm sorry. Let's plug in those values. We get 3 plus 2, comma. So again, my r is 3. My y sub 2 is 10. Plus s is going to be 2. And y sub 1 is 4. Divided by 3 plus 2. We simplify. 6 times 3 is 18. Plus 2 times 3 is 6. Divided by 5. Comma. This gives us 30 plus 8 divided by 5. Simplify some more. We get 18 plus 6. That should give us 22, I believe. 24. 24 divided by 5. And then the next one we get 38 divided by 5. Now, the nice thing about using this partitioning formula is that even though your partitioning point might not be the prettiest of points, you know it's accurate. You don't have to estimate a 0.5 or a 0.2 or whatever, because this fraction is completely accurate. So then we would just put a little box on it, and that would be our answer. Lesson 4, we jumped into slopes. So we actually saw the notion of slopes developed in partitioning right here. We call this rise over run, but we didn't define it yet. We just let you guys practice on it before we actually defined it. Again, this is a little bit of review. You guys should have seen slopes in Algebra 1 or your IM1 class. So with slopes, I gave you guys a story about jack. So if you're going up a mountain, it's positive, down a mountain, negative, flat surface, you're horizontal or zero slope, and then if you fall off the cliff, you're undefined because you are dead or do not exist. So just some vocab for you guys. We're going to rate the rate of change is also known as slope. So for slope, it's the change in y over the change in x. We got this y sub 2 minus y sub 1, that's the distance of y, and x sub 2 minus x sub 1, that's the distance of x. So let's go ahead and practice obtaining a slope using 2 points. Well, we know that this is our x1, y1, or our first point. This would be x sub 2, y sub 2. If we just plug those values in, we get 6, oops, it's y sub 2. We get, oh, came back. Oh, that's weird. All right, hopefully that works. There you go. We get y sub 2, so it's negative 4 minus 5, and then in the bottom we get 6 minus negative 2. Again, these two negatives give you a positive, and we get, when you're subtracting a negative, we're adding the opposite, so we get negative 9 over 8 is our slope. So that means if it's rise over run, that means we're going to drop 9 units, and we're going to go to the right 8 units to give us a slope. So we also talked about 2 theorems, in particular parallel lines and perpendicular lines. If 2 lines are parallel, we have the same slopes, or slopes are equal. So make sure you guys have this written down somewhere. It is actually very, very important. This as well, we have if 2 lines are perpendicular, then their slopes are opposite reciprocals, opposite inverse. Let's go ahead and switch that out. Oops. So this should be opposite reciprocal. Okay. So let's go ahead and practice. Oh, actually, we also talked about writing linear equations. So we have a linear equation written in point-slope form. So again, there's 2 pieces of criteria that we need for point-slope form. It needs to have a point, and our point is x1, y1, and it needs to have a slope, or m, which is our rise over run, or if you want to calculate it, because we're going to need the actual number for it, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we have the famous slope-intercept form. That's the y equals mx plus b form. So we need 2 pieces of information to graph in this. We need a slope and an intercept. Well, what intercept do we need? We need the y-intercept. So I'm going to call that y-intercept. Most commonly seen in our equation as our b value. And our slope, again, is just y equals mx. I'm sorry, it's just change in y over change in x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we use both of those equations to write linear functions. This is where you guys have a lot of difficulty, is actually writing a function given a point and a slope. So right off the bat, there's 2 things we got to do. Is first of all, read the directions, and then we have to write an equation perpendicular to the given line going through this point. So the given line here, we got to figure out whatever this slope might be. So I'm going to take a look at this point. I know that this point intercepts both my x and y axis nicely. And then I'm going to locate another one that does pretty much the same thing. Here it is. Let's look at that one. So I'm going to drop down a certain amount of units, and I'm going to go across. All I have to do is count. We go 1, 2, so that's a -2, and across 1, 2, 3. We go 3. So my slope for this line is going to be -2 over 3. So now, to use our point slope formula, we have our point slope, which is y minus y sub 1 is equal to m times the quantity of x minus x sub 1. Well, this is the point that we need. We have our point 0, -1, and our slope, since it's perpendicular, we got to do the opposite reciprocal. So what's the opposite of a negative? It's going to be positive. And a reciprocal just means we flip the denominator and the numerator. So this goes upstairs and this goes downstairs. So if we have all this information, we literally just plug in directly into our formula, and there is no other trick involved. So let's go ahead and write this out. I'm actually going to try to color code it to see if it makes a little more sense. I'm going to give you the slope in blue. So it's 3 over 2. So we have y minus my x1 is going to be green. I'm sorry, y1, which is -1, is equal to my slope, in this case, is going to be 3 over 2. X is going to be 0, so that works out. We actually have 1x minus x sub 1 is 0. There you go. And then I'm going to simplify. So these two negatives actually give me a positive. If I distribute to both, I end up with 3 over 2x plus 0, or plus 0. If I subtract to both sides, I subtracted 1 here, I subtracted 1 here, this goes away, I get y is equal to 3 over 2x minus 1. That is our slope. That is our equation. So you see, it just boils down to plugging it into something simple. What is simple? Well, it's this formula. It's our point slope formula. And then our final lesson for this part 1 was lesson 5, perimeter and area. Certain things you guys might want to write down are these formulas. The formula, the area of any rectangle or square is length times height, or base times height. So in case we don't know, this would be my base or my length, and this is my height. Well, very similarly, we have the area of a parallelogram, except we measure the height of the parallelogram from the top vertice to the straight down. So it's almost like the altitude of a triangle. It's from the vertice all the way down to the base. This creates a 90-degree angle. This gives us the absolute height, and then the base is just the exact same thing. Now notice for both of these, the perimeter is going to be the sum of all sides. Again, we have two more formulas. We have the area of a triangle and the area of a trapezoid. The area of the triangle is 1/2 base times height. Again, my height is going to be my altitude. It's going to be from vertex to base. And one last time, the height for my trapezoid is going to again be from the vertex to the base, except this formula is A, or the average of both my bases, A plus B, divided by 2 times my height. So since this has two bases, we got to take the average of them, then multiply by its height. And again, for my perimeter, it's going to be the sum of all of the sides, or the sum of all of the sides. Here's an example. We got to find the area of a parallelogram. So to find this area, first things first, we need to find the distance from B to C. Two different ways. You can apply the distance formula, or we can just count units. That's 1, 2, 3, 4, 5, 6, 7. So our distance here is 7 on top. If it's 7 on the top, it's going to be 7 on the bottom. For the height, we don't want the slanted side over here. That's distance of this segment AB. We want, again, the height is going to be from the vertex down to the base. And again, since it's a straight line, or it's just the y distance, vertical distance, we can count straight down. We have 1, 2, 3, 4, 5, and 6. So if my area for a parallelogram is base times height, I'm going to plug in my values. My base is 7. My height is 6. Meaning my area is going to be 42 units squared. And then if I want to find perimeter, I know that these two are 7. I got to find the distance between A and B. So we apply our distance formula again. This point down here is -5, -2. And this point up here is -3, 4. So my distance, let's do from A to B, is the square root of x sub 2 would be -3 minus x sub 1, which is -5 squared, plus y sub 2, which is 4, minus y sub 1 squared. We reduce that just a bit. We get negative, well, these two turn positive, so we actually end up with a 2 squared plus these two turn positive, 6 squared. We reduce just a bit more. We get 4 plus 36, which is just square root of 40, which if you do the factor trees, it just gives you 2 root 10. Yeah, 2 root 10. So meaning my distance here is 2 root 10. Whatever this side is also the same thing because a parallelogram has opposites congruent angles. Congruent sides. So there we go. If we want perimeter, that's going to be the sum of all these sides. So we get 7 plus 7 is 14. And then 2 root 10 plus 2 root 10. Well, if we have 2 of them, how many total root 10s do we have? We have 4 of these root 10s. This is your perimeter. All right. So the same exact thing here. We want to find the area of this trapezoid. To find the area of the trapezoid, we use our formula. It's going to be the bases or the average of both bases. So A plus B divided by 2 times my height. So let's go ahead and count this across. We get 1, 2, 3. So the distance here is 3. The distance here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4, 5, 6, 7, 8, 9. So my distance is 9. So let's go ahead and just plug in our values. We get 3 plus 9 over 2 times, what's my height? Well, my height is going to be from the vertex all the way to my base. That's 1, 2, 3, 4. So if I plug this in, I simplify this, I get 12 divided by 2 times 4. Or we get 6 times 4. Or we get 24 units squared is my area. To find perimeter, I would just need the slanted length here. To get the slanted length, again, you can use distance formula, or some of you guys already have found out that or know that it comes up, it's derived from Pythagorean theorem. So you know your distance is 4 here, and you know your distance is 3 here. So really, for my distance formula, you're going to end up having 4 squared plus 3 squared, which is 16 plus 9. 16 plus 9, which ends up giving us 25, which is just 5. So this distance is 5, which makes this distance 5. So my perimeter is 9 plus 3 is 12, plus 10 is 22. 22 units. Done. Alright guys, so that pretty much wraps it up. I'm going to also go ahead and upload these notes for you guys so you guys can follow along with the completed notes. This is part 1. So for part 2, we'll take a look at lessons 6, 7, and 10. Hope this helps, guys. See you all later. Bye.